this boat stops rocking, I guess, until a couple more folks might come in. But we'll be starting up in just a few moments.
This boat is a rocking. Don't come on up. Okay. Are we ready yet?
One could say that this boat isn't rocking, it's oscillating. But what's its fundamental frequency?
Okay. Hey, Michael, how's it going?
Good. How are you guys?
Good. We're going to have everyone mute their mics, and then
You got it.
we'll call on you.
You're rocking out.
Let's rock out at 0.5 hertz.
I don't know. One.
Okay.
Okay.
So everyone mute your mics, and we're going to start off with...
Stop oscillating.
We're going to start off
with
Ben. Maybe you can introduce the show.
Okay, welcome to the show and tell. We have 3 fine ladies here hanging out. Hey, Becky. Hey, Juan. Hey, me. The show and tell, we're going to have everyone show off their awesome project. If you're not showing off your awesome project, please mute your mic because I'm going to get feedback, and it's kind of annoying. I'll have to mute you, and it's frustrating. So mute your mics, and then we'll call on you in the order in which, like, you show up in the little down box thingy in the Google chat, and then yeah, we'll have like half an hour. We should have plenty of time.
Yeah.
I think.
Okay. All right. Hello, Ethan. Mute your mic. We'll get to you in just a few moments. And
First up,
go ahead, Ben.
Benjamin.
Hi. So I made these little. I'm sorry.
Don't be sorry.
I saw these. These are cool. This is the BeagleBone stuff, right?
Actually, this is a breakout of a comparator with some LEDs and delay RCs here.
Okay, but you do BeagleBone stuff, right?
Yeah, I do some BeagleBone stuff. But I hosted this workshop, and I wanted to do something a little bit more than just sewing lights into things, because I'm not very good at that. But I built this circuit based on Jerry Ellsworth, a video that she put up a long time ago, where you could have one patch with this comparator and then link up. I don't know if I can get both into there. So you have two of these comparators, and then you can link them up and just have these cascading lights or bifurcating lights. So the idea was to make this giant LED quilt, and we were somewhat successful. There wasn't enough time to make the quilt permanent, but with enough jumper cables, we got 10 patches together.
Oh,
Okay.
nice.
So you press one button and the LEDs like shimmer, or what?
Well, they just light up.
Yeah,
But then how does one control the other?
So with this yellow cable, the idea was that we would make these soft circuit cables, but we link from the negative side of one of the comparators to the beginning of the next patch, and then we tied the grounds together as well.
Okay. Okay. So it's like a little counter.
Yeah.
Okay. So your idea was to build a gigantic quilt with this, and then it would just slowly light up?
Yeah, but to allow the end user to sort of rearrange these connections as well.
Oh, I
nice.
see. Now I understand.
So that way you could you could bifurcate in a bunch of places if you wanted to, but you could also make a fully connected tree if you wanted to.
So so you're working on the quilt now, or that's like a future thing?
I have to get the users back together, or the participants back together. But yeah, they made the patches already.
Okay, cool. So now you just have to put them together.
Yeah.
And then what are you gonna do with this quilt? It sounds like it's gonna be scratchy. You're gonna hang it?
We were gonna hang it. It's at the Wonder Lab in Bloomington, which is sort of like a science exploratorium for a small city in Indiana.
Okay,
Oh,
cool.
that's awesome.
Great.
Yeah.
Well, you've been to Indiana?
I've been through Indiana, but I grew up right next to Indiana.
Oh, that's right. I thought you
Illinois.
Illinois.
The other long state
Sorry.
next to Indiana, which is
In
a
the
long
Midwest.
Yeah.
Very flat.
Corn.
Oh, Bloomington.
Hey, Ben, this is Phil. I'm off camera because I'm not as interesting as these three. Can you point the camera back down to the project? How do you like those little battery holders that you're sewing in? Are those working out for you?
I don't really like these things, but they're sort of... to make the sewing a little bit easier, I just soldered two of the battery holders together.
Okay.
And this one is actually fully soldered just because I needed to get some testing done. But this one was sewn by a participant.
Cool.
They're really crappy. Actually, the whole board, I forgot a pull-up resistor on my design, and I need to go fix that.
Hey, John, can you mute
No, you should do the talking. No, I should. You should.
Oh, from all of these still?
Block them?
Maybe it's not John. Does anyone know who that is?
The audio level, see that little green line?
Kevin Baker, mute your mic.
It's his fault.
Kevin.
Okay.
Okay.
Okay, we muted him. Right.
We thought we had
You
it.
can't talk anymore.
Okay. All right. Well,
Right,
thank
back
you so
to
much,
project.
Ben.
Yeah, that's
Okay,
really
great.
awesome.
Yeah,
Cool.
thanks.
Come back when the quilt is hanging, and we'll.
Okay.
Yeah,
just
I'll let you know.
keep your
Thanks.
mic muted until we call you. Otherwise, it'll sound like underwater robots. Okay. Thank you, James Cameron from underneath the sea. dialing it. Okay. Next up, we're gonna go to Eric Hall,
Who has a cube?
who has an awesome lab coat.
Whoa.
He does.
Yeah.
All right.
Dressed to kill.
I have a cube, more LEDs, but see that? Can you see that?
Yes.
Okay.
Try the mood cube at home.ransomhall.com.
We can.
Yes. I want folks to type that in, that URL, because you guys are going to be my load test.
So this is an internet cube.
Yes, I noticed you guys have been going crazy with the Internet of Things, and somebody's typing.
Yeah, I was on the site earlier when you posted it up. It's very cool.
Ah.
So, well, how does it respond to internet traffic? What's it doing?
So if you go to that site, you'll get the web server is the cube, is the lights. So there's a page there that lets you put in red, green, blue values.
Yeah.
You can also pick from about 15 different scripts. You can also set a fade time. That's about all I got on the page now.
Oh, so people go to the website and then they enter in the program that they want to run on your cube.
Exactly. Or actually, somebody did thunderstorms just now. So actually, I will go to the website when I want to set the mood at my home before my wife gets there.
Okay. Thunderstorms. Apparently, is the mood.
So it's only public for this special crowd.
Oh, okay. Not
I-
yet for full internet consumption.
Yeah, it's a little tricky to test it outside of my own house, so I wanted to see if I could actually get a few people to beat on it and break
Okay,
it.
it looks like it's pulsing and moving.
Be behaving.
What's running behind the scenes here? What's inside that box?
Inside that box is a NetMF board by GHI. It's one of their older ones, a Rhino. There are 4 Blink M's, the little Thing M Blink M's.
Mm-hmm.
Those are I2C. So the Rhino gets a URL, basically just parameters on the URL. The web server is on the board itself, and it says, oh, hey, somebody wants to make it change a color, and sends it off to, it's pretty straight up. It's awesome.
Very cool.
Yeah, we spent a lot of time, there were several guys on the NetMF forum that were really working hard on a web server because we had a lot of issues with some of the early code. But now that they've opened it up, it's awesome. So
Okay, great.
it's pretty solid. Yeah.
Very cool. And one last question: do you ever wear your lab coat outside the lab? And has anyone commented on these badges or anything? I'm just wondering.
Oh my gosh, you have an RTFM.
Yeah.
Ah, yes. As a matter of fact, this lab coat will make its public debut on Tuesday when I get to go do a Blinky show in front of a bunch of students at a local college hacker club.
If any of the students build something after you talk to them and get inspired, let me know, and I'll get you some badges to give to them.
Yeah. That's the whole idea. Is I got a whole stack of them as well.
Excellent. Okay, well, thank you so much, Eric.
Sure.
Good luck with your server. Hopefully we won't crash it too hard.
Well, I want you to. That's the idea.
Oh, I mean, hopefully we will. Okay, John Yang, you have a robot. I think I'm gonna have. Yeah. Okay, John, unmute your mic and show us your eggbot. I think it's an eggbot, right?
Can you hear me?
Yeah, we can hear you, John.
Yeah, great. So this is actually a Spearbot from
Is this a
Thingiverse.
robot talking, or is this a person?
So this is basically a copy of the Eggbot. So I used all the leftover electronics from my RepRap build. So these are 2 carrier boards that I designed that just hold the Flulu stepper controllers in our Arduino, and a small servo to move the pen, and I'm using the Unicorn plugin to generate the G-code from Inkscape. And right now it's just printing my son's name on a plastic egg.
Very cool. Is it functional? Can you turn it on and have it? Oh, there it is.
Cool. Just in time for Easter.
Yeah. Sam's gonna have the best Easter eggs.
So the diagonals are still kind of jaggy. I think it's the way the G-code is being handled by the Arduino. It's kind of doing stair steps instead of a clean diagonal.
This is pretty cool. All the people with RepRaps are like, I'm just tired of this whole 3D printing thing. Everybody's doing it now. I want to write on eggs. They could do this.
Yeah, it was 2 steppers, a servo, and just leftover RepRap electronics.
Do those Pololu boards do micro-stepping?
They do 16th, full step through 16th step. So they're set up for 16th stepping.
So when you're doing the diagonals, because one of the things I notice on like a lot of CNC tools is when they are trying to do routed corners, what they'll do is they'll slow down the moving machine head and then do like micro-step resolution to go around the corners, and then just do higher step resolution for straight lines that it knows that are on sort of its axis.
Yeah.
I don't know, is your G-code interpreter, like, if it doesn't have that, that might help you smooth out your diagonals.
Yeah, no, it doesn't do that. It's, the micro-stepping is set with jumpers on the carrier boards.
Oh, okay. So you'd have to, like, add that extra control line.
Yeah.
All right, well, thank you so much, John. This is very cool.
Yeah.
This is really awesome.
Yeah, next up, Kevin Baker, newcomer. We're going to ask you to unmute your mic now.
Can you hear me?
Yeah, we can hear you. You might have a little feedback going on. Oh. What's your project?
So, does this look familiar to you guys?
Oh, yeah.
This is the Charlie Cube. You guys featured it earlier this week, I think.
Yeah, everyone loves this project.
Yeah, so I wanted to show off the bottom of the board to prove that we're not hiding anything.
Oh, nice.
Oh, very cool. Your camera's on.
sorry,
Oh, no!
I think they're having internet lag.
We got some internet connection issues. Are you still there, Kevin?
I'm still here.
Okay, great.
That looks great.
Yeah.
Very cool.
That's totally awesome.
Yeah.
So we're using an Arduino Nano on the board.
Yeah.
We have plans to try to make it so that we can put an Arduino underneath it and just have it like sit on top of it, kind of like a shield. But right now, this is what it looks like.
And in like just a sentence, because I want to get to more people tonight, can you explain what you're doing to make all these LEDs? Charlieplexing is a term that people always want to know how you're doing this.
So the common cathode LEDs have 3 LEDs in the package, but if you rotate each one 90 degrees relative to each other in one spire, you end up with 12 LEDs, and you can go both directions and then address all 12 LEDs with only 4 pins. And you can go even farther and use just 16 pins on the base of the Arduino to control all 16 spires.
Very cool. That was a perfect explanation. Thank you.
Welcome. Thank you.
Okay, well, thank you so much, Kevin. Let us know if you update the project again. We'll do another post. We'll do a follow-up.
Will do. Thank you.
Okay, so we're going to try to get to 3 people in the next 15 minutes. Ethan, and then it's going to be Harriet, and then it's going to be Michael. So, Ethan, show us your project.
Okay, can you guys hear me okay?
Yep.
Okay, so, some minor progress on my helicopter project. See if you guys can see this. I've got some lag. But, so, this, oh, come on. There is my new PCB. It took a couple weeks of troubleshooting, but I got it to work eventually. And what happened was the boost converter on it kept cutting out and shorting, So I had to go through 4 PCBs before I could get it to work. And it's a good thing because I ordered 10 from Seed Studio. And right now, I'm trying to hook up this massive LCD so I can get some sensor feedback out of it.
Oh, great.
So I actually ran into a big problem tonight because MP Lab keeps shutting down when you start it up, so there's some bug in that software, but I got everything soldered in and nothing shorts out anymore, so I'm making some progress.
Yay!
And the boost converter I'm using is actually able to go down to half a volt before it cuts out. So I can use like a single AA for testing, or as much as 5 volts, and it'll always regulate to 3.3, which is pretty cool. And that should help my helicopter run longer.
So what is your self-imposed deadline? When do you want to start seeing this fly? When would you like that to happen?
Probably in 2 months.
2 months.
Because
Nice.
I can't work on it all the time. I wish I did, but
Do you have like a full-time job or something, or?
School.
Cool. Yeah. That's
To
great.
learn something there. But, I don't know. I wish I could do more electronics. It's way more fun to me.
Excellent.
So I started out with a board this big, and I went down half a stick, and let's see, quite a bit smaller. Need some better lighting.
You got Seed to give you a 1/32 inch board?
Oh, 0.8 millimeters, but it's actually, I went from about 9 grams to about 4 grams, which is quite a bit when you have such a small helicopter.
Yeah, 4 grams
So I
is,
think,
that's a really good reduction in payload.
yeah. So, and I added a lot more sensors and stuff, so it's just really exciting.
Nice.
Although it's kind of useless to have GPS on a helicopter that can only fly for 10 minutes. But, I don't know, I'm just going to see how far I can go.
Building
Like
for the
50 grams
future.
of olive oil.
I think you're building for better battery technology, and then it can run more than 10 minutes.
Yeah, that'd be great, but it can only go so far.
Okay. Well,
It's
thank you so
really
much,
great to sit there.
and stop back in the show as you get as you work on this, because it's 2 months, so that's 8 shows. So.
So, one other thing, this board, I designed it so I can do more high-altitude balloon stuff. So
Right.
it's the same board I'm going to use to do my next launch with your GPS.
Yes.
Perfect.
So apparently, you know, the firmware is set from the company, and we trust them that they did it. But you're probably going to be the first one to test. So thank you for testing.
I'm not quite sure when I'll be able to do it, but it'll probably be in at least the next 2 months because I have no idea how long it will take to get a balloon. Because last time it shipped to my house the day before we left to go launch it.
Yeah.
And it was about 3 months from when we called them and when I got back.
Jeez.
Oh, wow.
They could have sent it over balloon faster. Anyways. Okay. All right. We're going to move on. Thank you so much, Ethan.
Oh,
We'll see you maybe next week. And next up, it's going to be Harry, and then end the show with Michael. So Harry, show us your project.
Okay, dropping down to the other end of the scale. This is my latest stuff. It's really just more of a debugging process for an application that I'm working on, but it's dropping all the way back down to 7400 series logic chips, something I haven't done in a while. It's 2 7474D flip-flops running out to a 74139 dual 2 to 4 line decoder. So I have the 2 flip-flops, the 2 7474s, each of which have 2 flip-flops. That means I have 4 deep flip-flops total, so I can implement a 2-bit counter properly, or a 4-bit counter actually. And so the key being that in theory, if I just crank back up on my oscilloscope here, and that's it running from the current clock state, which I have running off of a 555, but I can drop in another clock state, which can be brought in by a function generator I have here. And so for those people who have never seen this, I'm sure you have, but for those people who have never seen this, a nice, interesting feature of doing this sort of thing is you get clock divided by 2 when it works, which it doesn't seem to be right now. Probably because I'm not wanting to clock convert it, but there we go.
Nice.
So there's it kind of spazzing out.
Yeah.
And so now there's clock divide by 2, as it's supposed to go. Now here's clock divide by 4, which is now there. And then, which if you can even see that. And then massively, here's clock divide by 8, which you're probably not even going to be able to see because of my scope, because I don't have a digital scope, I have a pure analog scope.
The edges.
Yeah, there it is. So it's kind of very at the very edge of the range. There's clock divide by 8. And so this will go into an application which will probably not be open source just because I'm working for another person who doesn't want it to be but it be used for some sampling applications. And then here's basically the same thing except in software with an ATtiny2313. That's the other way to do it. And I'm going. The guy I'm working for is old school. Like learned this in the 70s and the 80s. So he does everything. He does a rover control card with 3 breadboards of chips. And it took me a long time to be able to convince him. And Arduino does it pretty well too. And so hopefully, hopefully I can just show him this is one way you can do it, and this is the other way that you can do it.
That's kind of cool, but it challenges you to see how the stuff runs when you don't have access. When you don't have access, those constraints are kind of interesting.
That's how we did digital design when I was in college. With all TTL for life. So. Yeah,
no, it's nice to be able to. It's nice to drop back down to hopefully standard pinouts. Nice having 5 volts always in the same place and ground always in the same place. So yeah, that's kind of
very cool. Well, thank you so much. And if you're allowed to maybe post some photos of that demo that you just did.
I think I can clear that. I just can't talk about my specific application.
Yeah. Like a screenshot of this scope would be kind of.
Yeah. Well, I have schematic, but.
Yeah.
The schematic just looks like a bunch of blocks because it's all just a bunch of T flip-flops.
Okay, Harry. Well, thank you so much. We'll see you on a future show.
Next time, Carnot maps.
Yeah, I did some, and they're not fun.
And last up tonight, Michael, unmute your mic and show us your project.
How are you guys doing? First, I have to ask Ethan a question. Since he's into high-altitude balloon, is he getting his ham radio license?
Oh, I've been thinking about that. I don't know if I can convince my dad to help me learn, but actually, one of the challenges was I didn't know if I could. I was trying to do it without ham radio because I wanted to have a design open to everyone, even if they didn't have ham radio. But I think ham is looking pretty cool now, so.
Well, I mean, you can go for a call sign almost like mine, NE6RD. So I am the nerd.
All right.
So, and I also took...
The project is to get more people doing ham radio, I think, now.
Oh, yeah. Little product placement for you. That's how I decorated my new iPad. Okay, now my project. So I've been working on this for a while. I've got... am I on?
Yeah, you're on.
Yeah.
Okay, cool. Okay. So I've been working on something called an APRS transceiver. It uses the APRS technology, which is ham radio SMS, and you can throw GPS logos in there. So I have a board where I can get it twisted around without popping my wires. Okay.
Nice.
So the display is New Haven Designs. I like I to C. Nice, just a couple of wires. What you're looking there is a Argent Data radio shield on top of an Arduino, the connection bus in the middle, and once I get it going, you can see the 2 serial RS-232 TTL converters that will have, one will have a GPS, one will have whatever else you want to read data off of and send. I got a PS2 connector on this guy, and if you, let's see, in the chat, if you go to that URL, you'll see some messages I sent.
Oh, I think we can. Oh yeah, I see the chat right here. Yeah.
Okay.
Yeah. So it's.
If you guys, got a parrot.
Yeah. Oh, neat. Okay, so you're sending this
over.
So I'm sending this over APRS. It's digipeated until it hits what's called an iGate, which takes the message and sends it up to a service called APRS-IS, and then it winds up on the internet.
Okay. Nice. This is almost how we kind of use Twitter as an SMS gateway, right?
Yeah. But it's using.
It's using like satellites and like all sorts of radio.
There's no satellite. It's people putting up, ham radios with old school TNCs and doing repeats. I mean, I actually have to set a repeat path so they know how far to send the message.
Oh,
Okay.
And if you set your digipath wrong, and you look at APRS, they'll put your message in red saying bad path, meaning you're trying to repeat it too many times.
Oh, okay.
Really?
So I'll have this at the Maker Faire with additional features. I hope to have the GPS going, filtering as to whether or not you want to just hear from certain people or hear from anybody, whether you're sending a general message or a message that's meant to go to a specific station. So we'll see how far it gets, and I'll be publishing the code and the project in an announcement at my Maker Faire booth in May.
Oh, cool. And just because I'm not too familiar with some of this stuff, could you get this to go around the world with enough repeaters? Could you do a path around the world?
Nobody. It's possible, but nobody really does it. I would have to set a path that would cause way too many people to receive the message, and that would piss people off.
Yeah, that's ham spam.
Yeah, I mean, if you guys remember old UUNet stuff where you have to set the path.
Yeah.
Instead of direct point-to-point you put on a UUNet, this one is just the generic how many times is allowed to be repeated.
Right, in a sort of more open mesh topology.
Right.
Yeah.
Very cool.
Michael, what's your bird's name?
Yeah, what kind of bird do you have?
Kaik. We got a couple of minutes. Let me get her.
Okay.
Yeah.
Are we running out of time? Or?
We've got like 2 minutes.
It's show and tell your bird night.
I love Kaik. White-bellied, black-headed.
Waz has a bird.
I have a Kaik.
Yeah,
so
she has a bird, so
I
think she can communicate with
I
him
hear
directly.
I hear that call all the time. Oh, you have a black-headed one. Awesome.
Yeah, there's Elena. She's a Kaik.
Nice. She sounds exactly like mine. Now I know it's a species call.
Okay, so you understand what it's like to be woken up by something like this in the morning when she says, "Pay attention to me right now."
Every day.
Yes.
Aww.
Excellent.
Well, thank you.
Thank you.
Bringing people, their pets, and electronics together.
Yes.
Okay,
and I
everyone.
still plan on giving you those photos of the flea market in exchange for that book.
Totally fair trade. Love it.
Okay, cool.
All right. Well, thank you, everybody.
Bye.
Bye, guys.
And thank you, bird
Yeah.
friends,
Oh,
tuning in.
we're friends.
We'll see you on Ask an Engineer in just a few minutes.